So on this one, a couple things. What we're going to do is we want to identify the period, the amplitude, the phase shift, vertical transformation, the reflections, and the domain and range. All right. So first couple things, we just want to kind of understand, we have a couple of numbers in there. We need to really kind of represent, like, what do they stand for? What do they do? So if we look at our transformation equation, which is provided in our notes, all right, we know that the amplitude is just the absolute value of A, which in this case is the absolute value of 4, or 1/4, I'm sorry. So that equals 1/4, which is rather simple to do, right? The next one is going to be our period, which for period is going to be 2 pi over b. And again, b is what is going to be the coefficient of our x. So we can see here our b is 2. So in this case, we'll just have 2 pi over 2, which equals to pi. And that's important. If you remember, the amplitude was the half distance from the max to the min. And the period is how long it takes the graph. So if the graph originally took 2 pi and now only takes pi, you can see that the graph is being compressed, right? So technically, this is a horizontal compression. The 1/4 is also a vertical compression. And we'll talk more about those when I kind of sketch the graph, or at least the initial period. The next thing we want to look for is any reflections. And remember, reflections come when A is negative, which A is not negative, so there's no reflection about the x-axis. And when B is negative would be a reflection about the y-axis, which is not the case here at all. The next thing is we want to find the phase shift. So again, guys, remember the phase shift is technically C. Unless there is a B, that's when B stinks, right? So to find the phase shift, what we need to do, or at least to find the initial start, what we do is just take bx minus c, set it equal to 0. So in this case, I have 2x minus pi equal to 0. X equals pi halves. So what I'm actually doing is I'm shifting pi halves. Since that's positive, I'm shifting pi halves to the right. So my phase shift is going to be pi halves to the right. Okay? And it's very important for us to make sure that we are detailing where the graph is going, if it's shifting left, if it's shifting right. The next one is the vertical translation. That's basically saying, is the graph going up or down at all? And we can see here the graph is being shifted down too, right? Let me actually steal a little bit of your real estate, Kelly. The next one is our domain. And domain's rather simple, because as we looked at the graphs yesterday, you guys see these graphs continue on and on. So the domain is all real numbers. To understand the range, though, we're going to want to look at the graph. So I am going to graph the initial period. So there's the initial period. So if we graph kind of like the initial period, just like a rough sketch of it, this is what the sine graph looks like with no transformations, right? It goes to 2 pi, and pi, right? So let's think about what all this stuff happens. If I have an amplitude of 1/4, that means basically the half distance from the top to the bottom is 1/4. So now my graph is only going as high as 1/4 and as low as 1/4. So it's being vertically compressed, right? Now the graph is also being shifted, where is this, pi halves to the right. And technically, if you guys remember, that pi halves is right there. So technically, the graph is being shifted wait a minute. Yeah. So technically, the graph is being shifted over pi halves. But my goal of this is not for you guys to really graph. I just really want you guys to understand what's kind of going on. So I'll just leave that dotted, because I don't really care about you guys graphing it. But let's find the range. Let's look at the range here. Actually, I'm just going to delete this. I don't really care about you guys knowing how to graph it right now. All right. But does everybody understand how I shrunk the graph? OK. Because the range, it used to be -1 to 1. But now the range is -1/4 to 1/4, right? And then what we're doing is we're subtracting it down 1/4. So basically, the range looks like this. So basically, the range is going to be 1/4 minus 2 and negative 1/4 minus 2. Right? Because the range is basically from here to here, and you're subtracting 2. You're going down 2. Right? Here's the range, and you're subtracting 2, subtracting 2. So we got to figure out where that graph is. So we got to use a little bit of fraction operations. So we can rewrite this with the base 4. I knew I shouldn't have been talking. And when we go ahead and simplify this, we have a negative 7/4, negative 9/4. And there you go. All right.